Welcome back. This is an Aleks training video on identifying acids and bases by their reaction with water. On the left here, we've got compounds that once you put them in water, this is what's in the water. Okay, these are the things that are dissolved in the water, or the species in the water. From this, you should be able to tell whether something is an acid or a base, and whether something is a strong acid and a strong base, or also whether something is ionic or molecular. Now, the ionic and molecular we've done first. If you remember, if anything is two nonmetals joined together, then it will be covalently bonded and molecular. If you have something on the left side of the periodic table, a metal, joined with a nonmetal, something on the right, then you'll have an ionic bond, and it will be an ionic compound. So let's do that first, because that's, we did that back in October. So let's see what we got. We've got hydrogen and iodine. Hydrogen is a nonmetal, iodine is a nonmetal, so this has to be molecular, right? How about potassium and iodine? Potassium is a metal, it's in group 1. Iodine's a nonmetal in group 7, so it has to be ionic. Then we have nitric acid, which is nitrous acid, HNO2. Hydrogen is nonmetal, nitrogen's a nonmetal, oxygen is a nonmetal. So all these would be molecular. The last one, we have barium hydroxide. Barium is in group 2, it's a metal. Hydroxide is a polyatomic ion, negative. So this is a positive and a negative coming together. So this is ionic. So there's the first task would be to determine whether something is ionic or molecular, the compounds. Now look in what's in the water, and you should be able to tell if something is strong or weak. So let's look first of all at acids. Acids will give away an H, so you can see the acids here. This is going to act as an acid because it has an H to give. This is going to act as an acid here because this has an H to give. This can't be an acid. There's no hydrogen. This can't be an acid because your hydroxide is going to stay together, so the hydrogen is not there to break off. So this won't be an acid, this won't be an acid, but these two will. So if you have an acid, the hydrogen breaks off and joins to water, and you end up with an H3O+, which is called hydronium. So for you to determine whether something is acidic, you're looking for hydroniums. So let's see if there are any hydroniums here. Let's look in the first one. All right, so I see a hydronium here. This is hydronium. So that is acidic. I do not see hydronium here. Okay, so that's not acidic. I see a hydronium here. This is acidic. I don't see a hydronium on the last one. Right, so we know that compound A and compound C are acids, and let's look at the others. Ki is potassium and iodide and water. And the last one, barium and hydroxide and water. Well, hydroxide is what you're looking for a base. You're looking for hydroxides for a base. So D has to be a base. So let's look at B again. I do not see any hydronium. I don't see any hydroxide. So it's neither going to be an acid or a base. This is called a salt. So you have acids, bases, and salts. This is a salt. And so you're not going to check any of these boxes because it doesn't apply. There's no acid or base. So you can't have a strong acid if it's not an acid. You can't have a strong base if it's not a base. So let's go back and do strong and weak. So a weak acid doesn't completely break apart into protons plus an anion. It doesn't break apart into positives and negatives. So you're going to have some positives, you'll have some hydroniums, you'll have some of the negative conjugate base there, but you're also going to have, if it's weak, you're also going to have the compound. So you're looking here and say, okay, do I see any HI at all in the water? I see this, which means it's an acid. I see this, that's the conjugate base. I see the water, but I don't see any HI. That means that it's all dissociated and it has to be strong. So this, I'm looking for two things. I'm looking for the hydronium, so that's an acid, and I'm looking for the HI in the water, and I don't see it, so it has to be a strong acid. Okay, the next one. We've already seen that potassium iodide is not a base because there's no hydroxide. It's not an acid. There's no hydronium, so you don't check any of those boxes. The HNO2 has an H. That's a first giveaway. There's an H at the beginning, and so it's an acid. I confirm it by looking and seeing, do I see hydronium here, which I do. The H3O is hydronium. And then now, so it's an acid. Is it a strong acid? If it's a strong acid, there should be none of this in the water. Well, I do have some of this. That means that it's weak. It's not completely breaking apart. So if the compound is existent in the water, it's going to be weak. So this is an acid, and it's going to be a weak acid. And the last one, the barium hydroxide, you've got tons of hydroxide here, and hydroxide is indicating a base. So this is a base. Is it a strong base? Well, if it's a strong base, then there's none of this in the water. If it's a weak base, then there is this in the water. Well, there's none of this. There's no compound here, so it must have all dissociated, and that happens when it's strong. So this will be a strong base. So step by step,